students, welcome back to Chemical Kinetics. In this module of the chapter, we will understand how to represent rate of reaction with the help of equations. We have already seen the representation of rate of reaction graphically in the previous module. Now, I want you all to understand what happens inside a chemical reaction. The basic fundamental thing is that some reactants get converted into products. Now, while this is happening, the reactants, specifically I'm talking about reactants here, the reactants are getting consumed. They are disappearing with time. So understand this properly, students. The rate of disappearance of reactants, the rate at which these reactants are disappearing itself is the rate of reaction. So this rate of reaction, as we know, is change in concentration with respect to time taken. Now this change in concentration is nothing but decrease in the concentration of reactants. Because as I told you, the rate of disappearance of reactants itself is the rate of reaction. So this decrease in concentration of reactants upon time taken becomes your rate of reaction. Simple as that. I mean, come on, think about it. Say if the concentration of reactants is R1 at time T1. As this time progresses from T1 to T2, this concentration decreases to R2. Which means that as the time progresses, the reactant concentration decreases from R1 to R2. Now here I can say that the decrease in concentration is nothing but R2 minus R1, which is nothing but the change in concentration. Also, the change in time is nothing but T2 minus T1. These changes in concentration of reactants and time are represented by delta R and delta T, my dear students. So if I substitute this in the equation, what I get is delta R upon delta T. Now this makes a lot of sense because the change in concentration itself is the decrease. But if you think about it, R2 is smaller than R1 because the concentration is decreasing. So here the rate should be negative. Now that doesn't make that much sense. So what I do is I will multiply it by a negative sign. This extra negative sign will make sure that my overall rate is positive. You remember R2 minus R1 was negative, and negative multiplied by another negative becomes positive. So my overall rate of reaction remains positive, and also I come to know that the reactants are decreasing with time. So that's what you have to do. You have to write minus delta R upon delta T. The same logic can be applied to products. Again, consider this chemical reaction. The reactants are getting converted into products. Now here, my dear students, the products are appearing with time. They are not disappearing. The reactants were disappearing and the products are appearing. So I can say that the rate of appearance of products itself is the rate of reaction. Now that we are talking in terms of products, I can say that the rate of appearance of products is nothing but the rate of reaction. So this rate of reaction, which is change in concentration upon time, is nothing but the increase in the concentration of products with respect to time taken, because this increase itself is the change in concentration. Once again, let us say the concentration of products was P1 at time T1. As the time goes on from T1 to T2, this concentration of products is going to increase from P1 to P2. Now here I can say that the change in concentration of the products is nothing but delta P, which is final concentration minus initial concentration. P2, which is more, minus P1, which is less. Also, the change in time can be represented by T2 minus T1, which is delta T. So applying the same logic, I will substitute these two values in the formula right here, and I will get the rate of reaction is nothing but delta P upon delta T. Notice the positive sign here because the products will increase with time. So that's how you represent a rate of reaction. For the reactants, you need to make sure that there is a negative sign because the reactants are decreasing with time. And for the products, you have to keep a positive sign because the products are increasing with time. That is how you represent rate of reaction equation wise. That's all for this module. Let's take some example in the next module. So see you there. Till then, thank you.